Across cultures and centuries, mirrors have been more than objects of polished glass. They have been symbols, portals, and mysteries. People have stared into them not only to examine appearance, but to seek something deeper, an image of truth, a reflection of the soul, or perhaps a glimpse into a hidden dimension. Myths, from ancient Greece to modern folklore, tell of mirrors that reveal secrets, summon spirits, or even serve as gateways to worlds beyond our own. While most dismiss these stories as superstition, science has slowly crept toward ideas that sound strangely similar. At the heart of modern physics lies quantum theory, a framework so successful that it explains nearly everything we know about particles, atoms, and energy. Yet, the theory remains strange and unsettling. It suggests that reality is not fixed, that particles exist in many states at once, and that the act of observation itself plays a role in shaping what we see. Quantum mechanics invites us to rethink the boundary between what is real and what is possible. This is where the concept of the quantum mirror begins to emerge, not merely a poetic metaphor, but a thought experiment. What if a mirror did more than reflect? What if, in the right conditions, it became a surface that revealed another version of yourself, one that made different choices, lived a different life, and unfolded in a different branch of the universe? The idea may sound like fiction, but it builds on serious interpretations of quantum mechanics, including the many worlds hypothesis and the mathematics of probability waves. As we explore this theory, we will move carefully, chapter by chapter, from the foundations of quantum mechanics to the dizzying implications of encountering another version of yourself. Each step will be grounded in known science, extended with speculation where appropriate, and woven into a coherent arc that unfolds logically. By the end, we will not only have examined the science but also the philosophical, psychological, and existential questions that arise when considering such an encounter. Imagine standing in front of a mirror. You see your reflection, the shape of your face, the movements of your hands, the subtle shifts in posture. The image follows you perfectly, obeying every motion with mechanical precision. But a single unsettling thought begins to form. What if, instead of a reflection, the surface were a boundary? Not glass, not silver, but a thin partition between your world and another. And what if the figure on the other side was not simply a reflection, but another you, an autonomous version of yourself, gazing back through the frame of reality? This thought is not idle speculation. It rests on one of the most provocative interpretations of modern physics, that every decision, every random quantum event, splits the universe into multiple outcomes. In one universe, you turned left. In another, you turned right. In one timeline, you accepted a job offer. In another, you declined it. Each branching possibility generates an alternate world, unfolding in parallel, invisible, yet mathematically consistent. The mirror, in this framework, becomes a metaphor for contact across the divide. If the many worlds interpretation is correct, then countless versions of you already exist. They breathe, think, and live within their own universes, indistinguishable from yours but following different trajectories. Normally, these paths remain separate, never to cross. But quantum mechanics hints at phenomena, interference patterns, entanglement, tunneling, that suggest boundaries are not always absolute. Could there be conditions under which two parallel versions of reality touch? The unsettling part of the question is not whether these other selves exist, but what it would mean to confront one directly. If you were to meet another version of yourself, would you recognize them as you? Would they carry the same memories up until the moment of divergence, only to differ afterward? Or would the differences be so profound that they appear almost like a stranger, shaped by decisions you never made? Consider the psychological weight of such a meeting. A mirror normally reflects your choices back at you, your habits, your age, your expressions. But a quantum mirror would do something far more radical. It would reflect not what is, but what could have been. Every regret, every moment of hesitation, every untraveled path would suddenly have a living embodiment standing before you. This is not merely a curiosity of physics, but a profound challenge to the very notion of selfhood. Quantum theory forces us to confront the idea that reality is not singular. Superposition tells us that particles exist in multiple states simultaneously until observed. Entanglement shows that particles can share states across vast distances, as if reality itself were woven from invisible threads. The many worlds interpretation takes these principles to their logical conclusion. Every possible outcome is realized in some branch of the universe. Your life, then, is not unique in the sense of being the only version. It is one among an infinite spectrum. This leads us back to the mirror. The ordinary mirror shows you only one version, the one consistent with your current path. But what if, under extraordinary conditions, a reflective surface could align two versions of reality, overlapping them just enough to allow awareness to pass between? What if consciousness itself, entangled across universes, could glimpse through that surface? For centuries, humans have wrestled with the mystery of identity. Philosophers ask, are you the same person from moment to moment? Or are you a sequence of ever-changing selves held together by memory? Neuroscience adds its own complexity, revealing that memory is fragile and reconstructive, not a perfect recording. If identity is already fluid in one universe, what happens when two versions of the same self collide? The central question that drives this exploration is deceptively simple. What happens if you meet yourself in another reality? The answer touches physics, psychology, philosophy, and even spirituality. It challenges our understanding of choice, freedom, and destiny. It forces us to consider whether individuality is sacred, or whether we are but branches of an endlessly splitting tree. This is the doorway we step through in this series. From here, we will begin to examine the foundations of quantum theory itself, building upward until we can return to the mirror with new eyes. To understand why the idea of a quantum mirror has weight, we first need to establish the strange but reliable foundation of quantum mechanics. Classical physics gave us a picture of the universe as predictable and orderly. Newton's equations could describe the motion of planets, the fall of an apple, or the trajectory of a cannonball. In that framework, if you knew the initial conditions of any system with perfect accuracy, you could calculate its future state with certainty. This deterministic view dominated science for centuries. Then, in the early 20th century, experiments on light, atoms, and electrons began to reveal cracks in the old certainty. The universe, at its smallest scale, refused to obey the rules we expected. One of the first shocks came from the discovery of superposition. Instead of occupying a single definite state, quantum particles exist in overlapping possibilities. An electron is not in one place or another. It is described by a wave function that spreads across space, representing probabilities of where it could be. Only when measured does the electron appear in a specific location, as though the act of observation forces it to choose. Before measurement, its state remains fluid, existing in multiple outcomes simultaneously. This idea is not abstract philosophy. It was tested in experiments like the famous double-slit test. When electrons or photons are sent through two slits in a barrier, they create an interference pattern on a screen behind it, a pattern typical of waves, not particles. But when detectors are placed at the slits to determine which path each particle takes, the interference vanishes, and the pattern becomes that of ordinary particles. The very act of observing collapses the wave of possibilities into one concrete outcome. This simple experiment revealed one of the deepest mysteries in science. Reality does not appear to be fixed until it is observed. From this grew the concept of the wave function, a mathematical description of the state of a quantum system. The wave function encodes all possible states a particle can occupy. Its evolution is governed by Schrödinger's equation, which allows the wave to evolve smoothly over time. Yet whenever we measure, the wave collapses, and a single outcome is realized. The universe seems to operate in two modes: continuous unfolding of probabilities and abrupt collapse when interaction with an observer occurs. The term observer itself is not limited to conscious beings. In physics, it refers to any interaction that extracts information from a system. A detector, an atom, or even a photon bouncing off a surface can act as an observer. Still, the link between measurement and reality raises profound questions. If particles exist as clouds of probabilities until observed, then what does that say about the nature of the universe before anyone measures it? Was the moon only a cloud of possibilities before photons bounced off its surface and entered our eyes? Or does the universe contain an underlying reality independent of observation, with the wave function simply representing our knowledge of it? The debate split physicists into camps. The Copenhagen interpretation, championed by Niels Bohr, insisted that the wave function does not describe objective reality, but rather our knowledge of outcomes. According to this view, it is meaningless to ask where a particle is before it is measured. It exists in no definite state until the act of measurement crystallizes one. Other physicists, like Albert Einstein, resisted this notion. Einstein famously remarked, "I like to think the moon is there even if I am not looking at it." To him, the probabilistic view was incomplete. He argued that hidden variables must exist, underlying laws that determine outcomes even if we cannot see them. No hidden variables have ever been proven, though experiments like those testing Bell's inequalities strongly suggest that local realism, Einstein's preferred view, cannot explain quantum results. Instead, quantum mechanics appears to describe a world where chance, probability, and observation intertwine at the deepest level. This is the foundation upon which we begin to imagine realities branching, overlapping, and reflecting across one another. The observer effect is not just about particles. It challenges our concept of reality itself. If the universe requires observation to collapse probabilities into definite outcomes, then reality is not an independent objective block. It is participatory. The observer, whether conscious or mechanical, becomes part of the system. Without observation, possibilities remain open, suspended in a liminal state. This leads to questions that touch not only physics, but also philosophy. If reality is participatory, then are we co-creators of the universe? Do our acts of observation weave together the threads of existence? Superposition and wave function collapse also suggests that every outcome is encoded in the mathematics until the point of observation. That means the universe contains in some form the blueprint of every possible state. If you extend this logic beyond particles to entire systems, atoms, molecules, people, then the boundaries blur between what could happen and what does happen. It is a small step from there to the many worlds interpretation, where instead of collapsing into one outcome, the universe splits, and every possibility becomes real in its own branch. At the core, quantum mechanics teaches us that reality is not solid in the way we once assumed. It is probabilistic, shaped by interaction, and capable of existing in multiple configurations at once. This fluid foundation makes the idea of a quantum mirror conceivable. A mirror might not only reflect light from your face, but could, under extraordinary conditions, align the overlapping probabilities of multiple versions of you. In that fragile moment, you would not see a reflection. You would witness another possible self, embodied in another branch of reality. The groundwork is now in place. We have the strange world of superposition, the wave function that encodes possibility, and the observer effect that forces nature to reveal a single outcome. These concepts are unsettling, but they are verified again and again in experiments. They remind us that reality is not a fixed structure waiting to be discovered. It is dynamic, participatory, and more mysterious than common sense would ever allow. And in that strangeness lies the possibility that a surface as ordinary as a mirror might someday reveal far more than our physical appearance. When quantum mechanics first revealed its strange rules, many scientists searched for ways to explain how probabilities collapse into definite outcomes. For decades, the dominant explanation was the Copenhagen interpretation, which treated the wave function as a tool of knowledge rather than a literal description of reality. According to that view, superpositions vanish once measurement occurs, leaving only the result we observe. But in the mid-20th century, a young physicist named Hugh Everett proposed a daring alternative. Instead of assuming that one outcome survives and all others vanish, Everett suggested that every possible outcome continues to exist, but in a separate branch of reality. This proposal became known as the many worlds interpretation. It argued that the wave function never collapses at all. Instead, it continuously evolves, branching whenever a quantum event allows multiple possibilities. If an electron can spin up or spin down, both results occur. If a photon can pass through one slit or another, both paths unfold. When scaled upward, this means that entire universes are constantly diverging from one another. In each, events play out differently, yet all remain equally real. The power of Everett's idea lies in its simplicity. It does not require hidden variables, nor does it demand a special role for observation. It simply takes the mathematics of quantum mechanics at face value. Schrödinger's equation describes the wave function as evolving smoothly, with no mention of collapse. Everett asked, what if collapse never happens? What if our experience of a single outcome is merely the perspective of one branch, while countless others unfold beyond our awareness? Though radical, this view removes some of the conceptual puzzles of quantum theory. Instead of asking why the wave function collapses when observed, many worlds asserts that it doesn't. All possible outcomes exist, but observers find themselves inside one particular branch. From this perspective, reality is not a single line, but an endlessly splitting tree. Every quantum event produces new branches, and every decision we make is mirrored by alternate versions of ourselves making different choices. To visualize this, imagine flipping a coin. In everyday life, it lands either heads or tails. In the many worlds picture, the coin does both. The universe divides into two branches, one where it lands heads and one where it lands tails. In each branch, there is a version of you who saw the result. Neither is more real than the other. They coexist, diverging from the instant of the flip. Multiply this by every particle interaction, every human choice, every cosmic event, and the sheer scale of branching becomes unimaginable. This interpretation shifts our understanding of reality from a single unfolding story to a vast multiverse. The world you know is just one of many, a slice of a greater whole. Another version of you may have chosen a different career, moved to a different city, or spoken words you held back. In another branch, history itself diverges. Wars unfold differently. Discoveries are made earlier or later. Entire civilizations follow altered paths. Each universe is internally consistent, yet all exist in parallel, inaccessible to one another except in theory. Skeptics of the many worlds interpretation argue that it multiplies entities beyond necessity. Why postulate countless invisible universes when one will do? Yet defenders counter that the mathematics demands it. The equations of quantum mechanics do not erase possibilities. They evolve them. If we take the math seriously, then many worlds is the cleanest explanation. It avoids arbitrary rules about collapse, and it fits the data as well as any other interpretation. The cost, however, is the acceptance of a reality far stranger than common sense allows. Everett's idea was not widely embraced at first. It challenged the prevailing orthodoxy and seemed philosophically extravagant, but over the decades, it has gained a growing number of supporters among physicists who see its elegance. Modern research in quantum computing, which exploits superposition and entanglement, makes the many worlds view feel less like fantasy and more like a natural extension of the mathematics. If a quantum computer can process information across many states simultaneously, perhaps it is, in some sense, borrowing power from those parallel branches. The implications of this theory are staggering. If every possibility is realized, then there is no single, unique version of you. Instead, you are a constellation of selves spread across countless realities. Each carries the same origin up to a point of divergence, after which paths diverge. The version of you watching this right now exists alongside versions who are not, versions who made different choices earlier in life, versions who never encountered these ideas at all. The mirror, in this light, becomes more than a symbol. It becomes a thought experiment. What if the boundary between branches were thinner than we imagine? Meeting another self in the framework of many worlds would not require creating them. They already exist. The challenge would be crossing the boundary, aligning two branches that normally remain isolated. Physics tells us that interference between branches is possible under certain conditions, though it usually vanishes when systems grow large and complex. Decoherence explains why we do not notice superpositions in daily life. Interactions with the environment rapidly spread quantum information, separating branches beyond recovery. Still, if coherence could be preserved, the door might open to glimpses of parallel versions. The psychological weight of this is immense. It suggests that choice is both meaningful and illusory. Meaningful, because in your branch, the decisions you make define your experience. Illusory, because other branches embody the choices you did not make. Free will, in this view, becomes the experience of moving along one path, while countless others carry on without you. To meet another self would be to confront the reality of those paths face to face. The many worlds interpretation transforms the quantum mirror from metaphor to possibility. If reality is a branching tree, then the mirror might be imagined as a place where branches overlap, where you could catch sight of the self who stepped in another direction. It is this possibility that makes the concept so compelling. Not only does it challenge the boundaries of science, it forces us to reconsider what it means to be one individual among infinite versions. If the many worlds interpretation is correct, then infinite versions of you already exist. Each one carries your genetic code, your childhood experiences, and the same early memories. At the moment of divergence, however, paths separate. The question becomes, how much continuity is required for another version of you to still count as you? Are these parallel beings extensions of your identity, or are they strangers who happen to share the same origin story? Identity has always been a fragile construct. Philosophers as far back as Heraclitus argued that a person is never the same from moment to moment, because we are constantly changing in body and mind. Memory provides a sense of continuity, but memory itself is imperfect, reconstructed with every recall. Neuroscience shows that who we are is not a fixed essence, but a dynamic interplay of biology, experience, and environment. When applied to quantum branching, this suggests that a version of you who diverged years ago may feel less like a mirror and more like a distant relative. Imagine a version of yourself who made a single different decision 5 minutes ago. The divergence is minimal. Perhaps you took a sip of water instead of coffee. In that branch, you would still feel like the same person, with nearly identical thoughts and memories. Now consider a divergence 20 years in the past. Perhaps you chose a different career, married a different partner, or moved to another part of the world. That alternate self would still carry your childhood memories, but their adult life would be shaped by experiences foreign to you. Meeting them would feel uncanny. They would know your past, but they would not share your present. The strangeness deepens when you extend the timescale further. Imagine a universe where your parents never met, and another child was born in their place. That person would carry none of your memories, none of your experiences, yet in some sense, they still represent a possible outcome of your genetic and environmental blueprint, are they still you, or are they simply someone else altogether? The difficulty lies in defining what it means to be the same person. If identity is rooted in memory and continuity, then only branches with recent divergences would truly feel like yourself. Older branches would resemble siblings or cousins rather than true reflections. On the other hand, if identity is defined more broadly, as the totality of all possible states of a person, then every version across the multiverse is you, regardless of how different they become. In that view, identity is not singular, but distributed across an infinite set of lives. This raises profound questions about responsibility and meaning. If another version of you commits a crime in a parallel universe, does it stain your moral record? If another version discovers a cure for disease, do you share in the achievement? We instinctively answer no, because we are bound to the version of reality we inhabit. But if all versions are equally real, then your life is only one thread in a vast tapestry of selves. The boundaries of identity blur, and the notion of a single, isolated individual begins to dissolve. The mirror serves as a thought experiment for this concept. Looking into an ordinary mirror, you see a version of yourself bound to your choices and experiences. A quantum mirror, by contrast, would show you not just who you are, but who you could have been. The reflection might smile differently, carry a different posture, or speak with a confidence you lack. It might embody paths you regret not taking. Would you see that figure as yourself, or as a stranger who borrowed your face? Psychology offers insight here. Humans already experience fragmented identity in the form of roles and contexts. You are not the same person at work as you are with friends or family. Different aspects of your personality emerge in different environments. In that sense, alternate versions of you across universes are simply extensions of this fragmentation, magnified to cosmic scale. Meeting them might not feel entirely foreign. It might feel like encountering an extreme version of a role you could have played. Yet there is another possibility, that consciousness itself is not limited to one branch. Some theories suggest that awareness could be entangled across universes, giving rise to subtle feelings of déjà vu or intuition. If that were true, then alternate versions of you would not be wholly separate. They would be part of a shared network of selves, interconnected at a level beyond ordinary perception. In such a model, meeting another you would not be like meeting a stranger. It would be like recognizing a hidden part of yourself, brought into focus by contact across the boundary. The nature of the self across universes is not a question science can yet answer, but it is central to the quantum mirror hypothesis. The significance of such an encounter depends on whether you view the other as truly you, or as a statistical variation shaped by branching. If they are you, then the meeting is a reunion, a merging of perspectives. If they are not, then it is an encounter with someone eerily familiar, but ultimately distinct. Both possibilities are unsettling. Both force us to reconsider what it means to say I am. By framing identity in this way, we prepare ourselves for the deeper implications of crossing realities. The quantum mirror is not just about physics. It is about the fragile, shifting boundary between self and other. Whether that boundary proves porous or absolute will shape how we interpret the encounter, and whether we walk away seeing the reflection as another soul or as our own. From the beginning of recorded history, mirrors have carried an aura of mystery. They are more than polished surfaces. They are portals for imagination, tools for reflection, both literal and metaphorical. Ancient civilizations often viewed them as bridges between the physical and the spiritual, believing that to look into a mirror was to look into another dimension. That symbolic weight did not fade with time, it grew, transforming into psychological archetypes and eventually into speculative physics. In mythology, mirrors and reflective surfaces repeatedly appear as gateways. The Mayans crafted polished obsidian mirrors, not simply for vanity, but as ritual tools believed to open pathways to other realms. Shamans used them in ceremonies to communicate with ancestors or gods, regarding the reflection as a thin veil that separated one reality from another. Similarly, in ancient Chinese lore, mirrors were said to reveal hidden spirits, sometimes even warding off evil by reflecting it back on itself. They were not neutral objects but active instruments in shaping the balance between worlds. Western traditions also embrace the mirror's symbolic depth. In Greek myth, Perseus famously used a polished shield, essentially a reflective surface to face Medusa without being turned to stone. The shield was not just a weapon, but a symbolic mediator, allowing him to interact with danger indirectly through reflection. Later, during the Middle Ages, mirrors carried associations with vanity and deception, yet also with truth, since they revealed what was hidden in plain sight. They were paradoxical objects, sources of clarity and distortion, symbols of both knowledge and illusion. As time moved forward, literature transformed mirrors into metaphors for self-exploration and the uncanny. Lewis Carroll's Through the Looking Glass envisioned a world where stepping through a mirror led to an inverted reality, familiar yet strange. That idea resonates deeply because mirrors already present us with a reversed image. The person staring back seems to be us, but gestures, orientations, and expressions are subtly altered. We know it is only physics at play, yet psychologically the effect is unsettling. It feels as though the mirror holds another world waiting just beneath its surface. Psychology deepens this symbolism further. Carl Jung described the mirror as a metaphor for the human psyche, especially the process of individuation, the integration of conscious and unconscious parts of the self. To confront the mirror is to confront aspects of the self that might otherwise remain hidden. Children experience this dramatically in what psychologists call the mirror stage, when they first recognize their reflection as themselves. That recognition is both empowering and destabilizing. It anchors identity, but also highlights its fragility, a self that depends on reflection for confirmation. When quantum speculation enters the conversation, these layers of myth and psychology gain new life. If mirrors are historically symbols of gateways and psychologically triggers for confronting hidden aspects of the self, then imagining them as literal portals to alternate universes is not such a great leap. The symbolic groundwork has been laid for centuries. Quantum theory simply reframes that age-old intuition in scientific language, suggesting that what once lived in myth may hold physical possibility. A mirror does something subtle yet profound. It shows us ourselves from outside. Unlike memory or imagination, which are internal, a reflection gives a tangible, externalized version of identity. This externalization is what makes the idea of a quantum mirror so powerful. If there are countless versions of ourselves scattered across realities, then a mirror might serve as the perfect symbolic device for making contact with them. It already embodies the act of externalizing identity, of confronting oneself as another. This symbolic resonance explains why mirrors repeatedly appear in stories about thresholds. Horror tales use mirrors as devices for summoning spirits, because they intuitively feel like thin spots in the fabric of reality. Science fiction reimagines them as portals, tapping into the same archetypal association. Even modern technology, with its black glass screens reflecting faint images of our faces as we scroll, keeps the mirror's legacy alive. In each case, the mirror's meaning is never neutral. It always suggests more than a reflection. When connected to quantum theory, this symbolism becomes more than cultural coincidence. The act of reflection is itself a physical process. Photons strike the surface, bounce back, and carry information to our eyes. But what if some of those photons, at the quantum level, interact with alternate possibilities? The mirror, then, could be more than symbolic. It could be the stage where the physics of superposition, entanglement, and branching universes briefly intersect with human perception. The symbolic gateway becomes a theoretical one. The importance of this perspective lies not in claiming certainty, but in expanding possibility. For centuries, humans sensed that mirrors hinted at something beyond. Myths, rituals, and stories encoded that intuition. Psychology revealed how deeply mirrors influence identity and perception. Now, quantum thought experiments open the door to treating the mirror as a metaphor for multiple realities. What was once imagination becomes speculation, and speculation could someday transform into exploration. By recognizing mirrors as both ancient symbols and potential quantum devices, we begin to appreciate why they hold such fascination. They are not passive objects. They are active reminders of how reality, perception, and identity intersect. When you look into a mirror, you are not just seeing yourself. You are engaging with a concept that has haunted human thought for millennia. That the reflection might not be just a reflection, but a possibility waiting to be discovered. Among the most astonishing discoveries in modern physics is the phenomenon of quantum entanglement. When two particles become entangled, they are no longer separate in the way classical physics would expect. Instead, they share a state that binds them together across any distance. If one particle is measured and found to spin a certain way, its entangled partner instantly reflects a complementary spin, even if it lies on the other side of the galaxy. This instantaneous connection seems to ignore the traditional limits of space and time, baffling even Einstein, who famously called it spooky action at a distance. The reason entanglement matters for understanding the self is that it demonstrates how deeply connected the universe is at its foundation. What looks like separation in ordinary life may not be separation at all in the quantum world. If particles can be tied together so intimately, then what does that suggest about human beings, who are themselves built from trillions upon trillions of quantum events? The idea begins to emerge that perhaps our sense of individuality is incomplete, that maybe we are interwoven with versions of ourselves spread across possible realities. To appreciate the scale of this, imagine every choice you have ever made. Each fork in the road, each hesitation, each decision, however small, potentially gave rise to a branching path in the quantum landscape. According to some interpretations, those paths do not vanish. They persist in parallel, with another version of you continuing the alternate life. If quantum entanglement extends beyond particles to complex systems, then it could act as a hidden thread that links all those versions together, keeping them faintly aware of each other. At first, this seems wildly speculative, but the core principle of entanglement provides a precedent. The particles that make up your brain today might have entangled histories reaching far into the past, connected with systems that no longer share your physical space. The strange non-locality of quantum mechanics already shows that reality is not confined to local interactions. The suggestion that consciousness itself may exploit such entanglement, even faintly, is not beyond the boundaries of possibility. Consider what happens when two entangled particles are separated. Their connection persists until interaction with the environment forces decoherence, effectively breaking the quantum link. But if we think about the human self as a quantum process embedded within an immense web of probabilities, it becomes possible to imagine that some level of entanglement might survive across branches of reality. That would mean your alternate selves are not isolated copies. They may be entangled aspects of a larger whole, existing in different outcomes, but sharing subtle ties. This changes how we think about identity. Normally, we assume the self is bounded by skin and defined by memory. Yet if entanglement reaches into the structure of consciousness, then identity could be much wider, stretching across multiple worlds. You might carry faint influences from another version of you who chose differently, felt differently, or lived differently. Those strange moments of intuition, when you sense a path you never took yet feels oddly familiar, might hint at entangled echoes of your parallel selves. The physics itself remains mysterious, but experiments continually confirm the resilience of entanglement. In laboratories, researchers have entangled photons, electrons, and even small molecules. Distances have grown from centimeters to kilometers with no weakening of the correlation. Satellites have successfully entangled particles across thousands of miles, defying classical expectations. Each of these steps proves that quantum connections are not fragile quirks. They are robust, persistent features of reality. If such connections hold firm over vast space, might they also extend across the branching structure of alternate realities? This question transforms entanglement into something more than a technical phenomenon. It becomes a lens for rethinking what it means to be human. If at the most fundamental level everything is connected, then separation is an illusion. When we imagine meeting another version of ourselves through a quantum mirror, we may not be imagining a stranger. We may be glimpsing an entangled aspect of the same larger identity, a piece of the self that has traveled a different path, but never fully detached. The mirror in this context is more than reflective glass. It symbolizes the act of tuning into those entangled connections. Just as scientists use detectors to reveal the correlations between particles, perhaps the human mind could serve as an instrument to sense entanglement with alternate selves. What we experience as dreams, intuitions, or uncanny familiarity could be weak signals from those hidden ties. The mirror, both physical and metaphorical, is the place where those signals might be brought into focus. Such an idea invites profound reflection. If every choice resonates across entangled selves, then morality, responsibility, and meaning take on new dimensions. Your actions do not only shape your path, they ripple into the network of your other versions, influencing the larger whole of your existence. Conversely, you may be influenced by decisions you did not make, but which another version of you enacted. The self becomes a chorus rather than a solo, harmonized by quantum connections that transcend a single timeline. Science has not yet confirmed these possibilities, but the building blocks are in place. Entanglement is real, measurable, and indispensable to the structure of the universe. Its implications extend beyond physics into philosophy, psychology, and identity. To speak of the connected self through entanglement is not to abandon reason, but to follow the evidence of quantum theory to its most radical and human conclusion, that we may all be linked to ourselves across realities. At the heart of quantum mechanics lies a language that translates mystery into precision. Mathematics. When we try to imagine how a mirror could serve as a thin boundary between realities, we must look beyond surface-level symbolism and into equations that describe how light, probability, and superposition operate. Reflection is not simply light bouncing back. It is a quantum event that involves probabilities, wave interference, and boundary conditions. The mirror we see hanging on a wall is therefore only the visible tip of a mathematical iceberg. When light strikes a reflective surface, quantum mechanics tells us that every photon is a probability wave. Instead of traveling along a single fixed path, the photon explores many routes simultaneously. Richard Feynman, one of the great physicists of the 20th century, explained this through the path integral formulation. Each photon doesn't just take the shortest route, but samples every possible trajectory, assigning probabilities to each. What we perceive as reflection is the interference of all these paths resolving into a coherent outcome. At this level, reflection is already stranger than common sense allows. A mirror is not just reversing an image. It is guiding probability waves into patterns that our eyes interpret as coherence. The mathematics describing this involves boundary conditions, which specify how waves behave at the edges of materials. When a wave hits a mirror, the surface enforces a condition that flips part of the wave while transmitting another fraction. The result is interference that appears to us as a clean reflection. But mathematically, it is a negotiation between countless possible outcomes collapsing into one observed event. Now consider what happens if we push this reasoning further. If a photon exists in superposition until observed, then during its interaction with a mirror, it carries the potential of multiple outcomes. In some branches of the quantum wave function, it bounces back toward your eye. In others, it may tunnel deeper into the reflective surface, or even emerge at slightly different angles. Each of these alternatives represents a different quantum history. In the language of the many worlds interpretation, all outcomes exist, but only one is visible to you in this branch of reality. The mathematics of superposition suggests that when you see your reflection, you are not simply looking at a deterministic image. You are perceiving one outcome out of countless possible reflections. Most collapse into invisibility, but they are still encoded in the quantum wave function. This is where the notion of a mirror as a boundary between realities gains traction. The visible reflection is your world's outcome. The invisible reflections belong to other branches, each hosting a version of you that perceives a slightly different result. The mirror becomes not just a surface, but a mathematical intersection where probabilities divide. Equations that govern this, such as Schrödinger's equation, reinforce the idea. Schrödinger's framework describes how wave functions evolve over time. When applied to photons and reflective surfaces, it shows that reflection is not instantaneous, but a process of interaction, interference, and resolution. Within this process, wave functions extend beyond the mirror's surface, creating what physicists call evanescent waves. These are faint, ghost-like extensions of the probability wave that penetrate the boundary before fading. One could imagine these evanescent waves as subtle bridges, momentary footholds where alternate outcomes overlap. If we extend this interpretation, the mathematics does not forbid the idea that reflections could contain more than one world. Each solution to Schrödinger's equation corresponds to a possible state. Most remain hidden from observation, but they still exist within the full wave function. When we stand before a mirror, the mathematics quietly insists that countless invisible reflections accompany the visible one. They are not mere illusions, but alternate outcomes mathematically permitted by the laws of physics. The challenge lies in accessing them. Another mathematical angle comes from quantum field theory. In this framework, particles are excitations of underlying fields that extend across the universe. A mirror interacts with these fields, shaping how excitations emerge. Boundary conditions in field theory do not only define reflection, but also create what are known as vacuum fluctuations. These are tiny ripples of energy that appear even in empty space. Some physicists speculate that such fluctuations could interact across boundaries, hinting at communication between neighboring realities. A mirror, by shaping these conditions, could act as a stage for cross-reality interference. Even more provocative is the role of symmetry. Mathematics shows that reflection symmetry, what we casually call a mirror image, extends deep into physical laws. Particles and interactions often come in pairs of symmetrical states, but in some cases, that symmetry is broken, producing subtle differences between matter and antimatter, or left-handed and right-handed interactions. Mirrors highlight this tension between symmetry and asymmetry. They seem to present a perfect reversal, yet they conceal deeper asymmetries. If alternate realities are structured around different symmetry breakings, then mirrors could mark the thin border where these divergences touch. This perspective reframes a simple act. Looking into a mirror is not trivial. It is standing at a site where mathematics describes probabilities splitting, wave functions overlapping, and symmetries negotiating. The reflection is a visible outcome, but the equations tell us there are countless unseen ones. What if, under certain conditions, we could enhance those faint contributions, amplifying the invisible reflections until they become perceivable? That would transform the mirror from a metaphor into a literal boundary between worlds. The mathematics does not guarantee such access, but it leaves room for speculation. Quantum mechanics is filled with possibilities that seemed absurd before experimental confirmation. Entanglement, tunneling, and superposition all sounded implausible until evidence forced us to accept them. Reflection, when viewed through this lens, is not the final image, but the negotiation of many realities resolving into one. To stand before a mirror is to stand before probabilities collapsing, and perhaps, just beyond the glass, other versions of yourself watching their own collapses unfold. If mirrors can be treated as boundaries where probabilities divide, the next question is how an actual interaction across those boundaries might unfold. Physics offers us a few intriguing candidates: quantum tunneling, interference, and the overlap of probability waves. None of these mechanisms has been demonstrated to connect parallel realities, but each contains mathematical structures that could, in theory, allow a crossing or an exchange of information between versions of the self. Quantum tunneling provides the first possible route. In ordinary circumstances, tunneling allows particles to pass through barriers that should be impenetrable. An electron facing an energy wall, for example, sometimes appears on the other side without ever climbing over it. The mathematics behind this is clear. The particle exists as a probability wave, and part of that wave extends beyond the barrier. Although the chance of emergence is small, it is never zero. If a mirror is seen not just as a reflective surface, but as a quantum boundary, then tunneling suggests the possibility that parts of our probability wave might seep across into adjacent realities. Meeting another version of yourself might not require smashing through universes, but slipping softly through the thin cracks that tunneling permits. Interference offers a second path. In quantum mechanics, probability waves can overlap and combine, either amplifying or cancelling each other. This is most famously demonstrated in the double-slit experiment, where particles passing through two openings create an interference pattern, even when fired one at a time. The implication is that each particle behaves as though it travels through both slits simultaneously, interfering with itself across possibilities. Now imagine two versions of you, each existing in parallel. If their probability waves overlap in the right conditions, interference could manifest not as an abstract pattern on a screen, but as a momentary blending of realities. This blending could produce fleeting awareness, or even direct contact between alternate selves, as though the boundary blurred enough for one version to glimpse another. The idea of overlapping probability waves deepens this scenario. Every quantum system is described by a wave function, which defines all possible states until observation collapses them. Normally, wave functions from separate systems remain distinct, but in certain cases, they can overlap and form entangled states. If the wave function describing you extends into multiple branches of reality, then there might be regions of overlap where different versions of your identity coexist in a shared probability space. Those regions would not be stable in the way we usually understand stability. They would flicker in and out of coherence, yet during those flickers, contact could occur, enabling a form of interaction that is neither physical nor purely mental, but a quantum resonance between possibilities. Bringing these ideas together, one can imagine a mirror acting as a focus point. Photons striking the surface already exist in superposition, spreading across multiple outcomes. If those outcomes align in a way that allows interference, the mirror could highlight overlaps between realities. Add the tunneling effect, small parts of your probability wave slipping through, and the mirror becomes more than reflective glass. It becomes a channel, fragile but mathematically conceivable, for exchanging signals across branches. Meeting yourself would then depend on synchronizing with those rare conditions where tunneling and interference align to create overlap strong enough to sustain awareness. What would such a meeting look like? Theoretical mechanics suggests it would not resemble a physical handshake across realities. Instead, it might manifest as sudden recognition, as though your thoughts briefly aligned with those of another version of you. It could take the form of patterns in the reflection that do not match your movements, subtle discrepancies revealing the presence of a self governed by slightly different choices. The communication would likely be fragmented, fleeting, and fragile, because the quantum overlap would not hold long against the environment's tendency to enforce decoherence. Yet even a momentary glimpse would confirm the existence of parallel identities and their entanglement with your own. Skeptics argue that such overlap would be too delicate to notice. Decoherence. The process by which quantum superpositions collapse due to environmental interaction happens almost instantly in macroscopic systems like human beings, but others counter that decoherence does not destroy possibilities. It merely hides them from direct observation. The mathematics still contains all outcomes, even if our instruments cannot yet reveal them. If we treat the human mind as more than a passive observer, perhaps consciousness could serve as the instrument sensitive enough to perceive overlapping selves. Some theorists speculate that awareness itself operates on the edge of quantum processes, giving us an entry point into phenomena otherwise inaccessible. The practical mechanics of such a meeting might one day be probed through controlled experiments. By manipulating interference patterns with high precision, scientists already demonstrate control over photons and atoms in superposition. Expanding this control to larger systems remains a monumental challenge, but the principles do not forbid it. If technology advances to the point where we can engineer sustained overlaps between probability waves at macroscopic scales, then the act of meeting yourself in another reality might shift from speculation to demonstration. Even without experimental proof, the theoretical groundwork suggests that interaction across realities is not beyond imagination. Tunneling provides the mechanism for crossing barriers. Interference provides the mechanism for blending probabilities. Overlap provides the framework for shared existence. The mirror, in this interpretation, is not merely a metaphor, but a mathematically plausible stage where these mechanisms converge. It is the point where physics whispers that another you is close enough to touch. If only the boundary could be made thin enough. The human mind is built on continuity. We wake each morning with the assumption that we are the same person we were yesterday, carrying memories, habits, and a sense of direction that holds identity together. Now imagine that continuity suddenly colliding with its own reflection, not the familiar reflection of a mirror that follows your movements, but a conscious encounter with another you. This other version shares your genetic code, your childhood, and your early experiences, but diverges at some crucial point where choices or circumstances branched off. Such a confrontation would not be like meeting a stranger. It would be like staring into the living proof that your life could have unfolded differently, and that identity itself is not singular, but plural. Psychologists often describe identity as a narrative, a story you tell yourself to maintain coherence. It ties together scattered events into a timeline that feels stable, even when life shifts dramatically. Meeting another you threatens that story at its foundation. Suddenly, the narrative fractures, and instead of being the only protagonist of your life, you are forced to recognize that the story has multiple versions running in parallel. For some minds, this could be a liberating revelation. For others, it might create a shock so profound that the story collapses under the weight of contradiction. Consider the first moments of such an encounter. Seeing another you would mean confronting both recognition and alienation at once. The face would be familiar, the voice almost indistinguishable, and yet the mannerisms, tone, or choices of words would betray divergence. Psychologically, this could create cognitive dissonance, the mental stress that arises when two contradictory truths must be held at once. One truth says, I am unique, there is only one me. The other says, here is evidence that I am not singular, but one branch among many. The collision could generate confusion, denial, or even outright rejection, as the mind struggles to protect the stability of self. Yet the shock could also open new dimensions of awareness. Imagine seeing a version of yourself who pursued a different career, maintained different relationships, or avoided mistakes that you regret. The sight might initially sting, fueling envy or shame, but it might also expand the horizon of what you believe possible. If another you exists who chose differently, then your own life is not a fixed line, but one path among countless options. This realization could break the sense of inevitability that often weighs down human lives, offering freedom instead of despair. The expansion of identity might mean accepting that you are not bound to a single version of yourself, but connected to an entire spectrum of possibilities. Clinical psychology provides clues to how people might respond to this kind of identity rupture. Encounters that shake self-perception, such as near-death experiences, major trauma, or profound spiritual events, often split individuals into two groups. Some spiral into disorientation, unable to integrate the new perspective. Others adapt, weaving the shock into a broader sense of meaning that ultimately strengthens their identity. Meeting another, you could follow this same pattern. For some, it would shatter the coherence of the self. For others, it would broaden the definition of who they are, creating a multi-layered identity that includes not only the person they became, but also the people they could have been. Philosophers might call this encounter a direct challenge to essentialism, the belief that there is a single, unchanging essence at the core of each person. If you meet yourself and find differences that run deeper than trivial details, then essence itself becomes unstable. Are you defined by the decisions you made, or by the infinite array of decisions you might have made? Does identity rest in continuity of memory, or in something subtler like shared potential? These are not academic questions when your other self stands before you. They become urgent puzzles of survival, because the answer determines whether your mind can hold together in the face of contradiction. The emotional weight of such a meeting cannot be underestimated. Imagine the guilt of seeing a version of yourself who made choices that spared others pain, while your own choices caused harm. Imagine the pride of seeing a version who failed where you succeeded, reinforcing your confidence in the path you walked. Imagine the bittersweet longing of meeting a self who loved differently, whose relationships brought joy or heartbreak that you never experienced. Each of these encounters would act as a mirror for your own life, amplifying every regret and every triumph. The psychological consequence would depend on whether you interpret those reflections as validation, condemnation, or possibility. Neurology adds another layer to this speculation. The brain relies on prediction as much as perception, constantly anticipating outcomes to maintain stability. When confronted with something radically outside its predictions, the brain often reacts with stress responses, flooding the body with adrenaline and triggering fight or flight instincts. Meeting yourself could easily provoke this cascade overwhelming rational thought. Yet if the encounter persisted, the brain might adjust, creating new predictive models that include the existence of alternate selves. In this sense, the shock would not only test psychology, but also force neurological rewiring, pushing the mind toward an expanded model of reality. From a cultural perspective, humans have long wrestled with doubles. Folklore speaks of doppelgangers as harbingers of death, while literature explores the terror and fascination of confronting another self. These traditions reflect a deep intuition. Meeting oneself is destabilizing because it collapses the distance between the familiar and the unknown. The other you is both intimate and alien, and that paradox stirs unease. Yet within the unease lies an opportunity. If integrated, the encounter could mark the beginning of a new stage of human self-understanding identity, no longer as a single thread, but as a woven fabric of possibilities, each thread as real as the one we inhabit. Ultimately, the psychological consequences of meeting yourself would depend on preparation, perspective, and resilience. For some, the shock would fracture identity, leading to denial or breakdown. For others, the same shock could act as a catalyst for growth, dissolving rigid boundaries of self and expanding consciousness. The difference lies not in the encounter itself, but in the capacity of the mind to embrace multiplicity, to see yourself not as one being trapped in a single line of time, but as a node in a vast quantum web, where every choice reverberates into countless forms of existence. The image of a mirror has always suggested separation. Two sides, one real and one reflected, with glass dividing them. Yet what if that division were not absolute? Instead of a simple visual imitation, imagine the mirror functioning as a thin quantum membrane, one capable of transmitting not just images, but states of awareness. Under this view, standing before your reflection would not simply mean observing yourself, but entering into the possibility of shared consciousness with the alternate self staring back. In cognitive science, consciousness is often described as an emergent phenomenon, a product of countless neurons firing, integrated into a coherent experience of self. But if consciousness emerges from quantum processes within the brain, as some researchers suggest, then those processes may not be isolated. Quantum states can extend across boundaries through entanglement, interference, and resonance. A mirror, acting as a unique boundary between overlapping probabilities, might provide a medium where consciousness is not confined to one body. Instead, awareness could ripple across realities, blending the experience of two selves into one expanded field. To imagine this more concretely, think of two musical instruments tuned to the same frequency. When one string vibrates, the other begins to resonate, even without direct contact. Consciousness might operate in a similar way when conditions align. If two versions of you approach the mirror simultaneously, each carrying parallel but diverging streams of awareness, the mirror could act as the resonant chamber, amplifying the overlap until thought, memory, and perception begin to intermingle. The result would not merely be seeing another life, it would be feeling it, living it in real time, as though two perspectives had been fused into a single act of awareness. This idea carries profound implications. Shared consciousness means that individuality itself could be permeable. The concept of self as private, contained, and solitary would collapse, replaced by a model where identity is a network of linked experiences. Your choices and memories would not be yours alone, but part of a larger continuum shared with countless alternate versions. What would it feel like to suddenly know the regrets, joys, and fears of another self, not as second-hand stories, but as lived experience flooding into your own mind? The encounter could redefine empathy itself, not as imagination, but as direct access to the lives you never lived. There are, however, risks inherent in such a merging. If the stream of consciousness is too overwhelming, the boundary of self could dissolve entirely. Individual identity might be drowned in the flood of memories and perceptions from another reality. Psychologically, this would resemble the dissolution of ego described in mystical traditions or psychedelic states, where the sense of I disappears into something larger. Some might interpret the merging as transcendence, an escape from isolation into collective awareness. Others might experience it as annihilation, a loss of the stable center that grounds existence. From a theoretical standpoint, quantum mechanics offers mechanisms that could support such a bridge. The observer effect demonstrates that consciousness and measurement are intertwined. Superposition suggests that multiple realities coexist until resolved by observation. If two conscious observers on either side of the mirror are entangled through this thin boundary, then the act of observation might not resolve the wave function into one outcome, but instead allow both states to be partially experienced simultaneously. This overlap would create a momentary shared self, a consciousness inhabiting two realities at once. One could argue that dreams already hint at such possibilities. In dreams, the mind often generates identities that feel both familiar and alien, as if they belong to versions of us that live elsewhere. If dreams are indeed windows into parallel states, then the mirror as a bridge might function as a waking dream, an intentional alignment where conscious selves touch across dimensions. Unlike dreams, however, the contact would not dissolve upon waking. The knowledge, the emotions, the raw experience of another life would remain within you, integrated into your memory as though you had truly lived it. The cultural consequences of such a phenomenon would be staggering. Imagine political leaders suddenly feeling the weight of decisions they did not make in other worlds, experiencing the devastation or prosperity that alternate choices created. Imagine artists merging consciousness with their alternate selves, discovering creative insights shaped by entirely different lifetimes of experience. Imagine ordinary people confronting the lives they might have lived had they made small changes, choosing another city, another partner, another moment of courage. The mirror would no longer be a passive object, but a gateway to expanded identity, transforming society into a tapestry woven from interconnected minds. Yet for all its potential, shared consciousness also raises ethical dilemmas. If you merge with another version of yourself, who owns the resulting awareness? Are the memories and insights you gain truly yours? Or do they belong to the alternate self, whose experiences you absorbed? What if one self resists the merging, fearing loss of individuality, while the other embraces it? These conflicts would force humanity to redefine the boundaries of selfhood, ownership of thought, and even personal responsibility. At the deepest level, the mirror as a bridge suggests that consciousness is not confined by the brain, but exists as a field phenomenon that can span boundaries. This aligns with theories in quantum biology that propose coherence effects within neurons, allowing consciousness to interact with non-local states. If so, then the mirror's surface may act as a synchronization point, aligning the frequencies of two selves until awareness leaps across the divide. For the individual, this would feel like an awakening, a sudden expansion of perspective, where the line between me and other me dissolves into shared being. The prospect is both awe-inspiring and unsettling. To see yourself is one thing. To become yourself in another reality is another altogether. The mirror ceases to be a simple object of reflection and becomes a threshold to collective identity. Standing before it, you are no longer alone. You are a chorus of possibilities, a living network of selves connected by the fragile yet profound bridge of consciousness. The mirror as a bridge raises possibilities that stretch imagination, but with possibility comes risk. Among the greatest dangers is paradox, the collision of events across realities that should remain separate. A paradox emerges when cause and effect no longer align in a stable chain, when action and consequence twist into a loop that defies consistency. While paradox is often treated as a philosophical puzzle or a trope of science fiction, in the context of quantum realities, it could represent a genuine threat to coherence itself. If you were to reach across the mirror and influence another version of yourself, the consequences might ripple not just through one life, but across universes, destabilizing both in ways we can hardly predict. To grasp the severity, it helps to imagine a simple scenario. Suppose you stand before the mirror and share awareness with another you, one whose life diverged at a crucial decision. In your reality, perhaps you chose to abandon a particular career. In theirs, they pursued it. If you warn them of the failures you anticipate, they might alter their path, undoing the very divergence that created their world. In that moment, the logic of branching collapses. Two universes that depended on difference to remain distinct now face the problem of convergence. What happens when two realities try to collapse into one? Paradox challenges the very structure of the multiverse as proposed by the many worlds interpretation. That interpretation relies on every possibility branching outward, never intersecting again. Paradox is the opposite. Branches curving back toward one another, forcing reconciliation where none should exist. Quantum mechanics is not built to accommodate such feedback. If two realities attempt to fold into each other, the superposition may no longer resolve cleanly. Instead, the interference could lead to instability, a collapse of probabilities that ripples outward, unweaving not just the two branches, but the coherence of the wider multiverse. One way to visualize this is through the metaphor of resonance. Two strings vibrating at slightly different frequencies can coexist, each sustaining its own sound. But if one string tries to force the other into its exact frequency, the result can be destructive interference. The waves cancel, leaving silence. A paradox may function in the same way, an attempt to force coherence between realities that must remain distinct, resulting not in harmony, but in collapse. In such a case, both realities might disintegrate, their probability waves dissolving into noise. The human role in creating paradox cannot be overlooked. Awareness is not passive in quantum mechanics. Observation shapes outcomes, and interaction amplifies the shaping effect. If two versions of yourself begin to coordinate across realities exchanging advice, altering choices, or even directly influencing behavior, then the neat separation of worlds erodes. Each reality begins to depend on knowledge gained from the other, creating loops of causality. Such loops are inherently unstable, because they break the forward arrow of time and replace it with circular logic. If a choice is made because of knowledge gained from another universe, that universe may cease to exist as it was, thereby erasing the conditions that allowed the knowledge to be shared in the first place. Philosophers of time often describe paradox as self-negating. The classic grandfather paradox, for instance, describes a traveler who prevents their own existence by altering the past. In the case of parallel selves, the paradox takes on a mirrored form. By altering your alternate self, you unravel the divergence that made their existence distinct. Unlike fiction, however, the consequence would not be a tidy erasure or a reset. In the quantum framework, paradox could mean a tearing of probability space, a kind of informational collapse that spreads outward like cracks through ice. Even on a psychological level, paradox is dangerous. The human mind seeks coherence, constructing narratives that align events into cause and effect. When confronted with contradictions that resist resolution, the mind suffers strain. This can be seen in cognitive dissonance experiments, where even small contradictions cause discomfort until the mind reshapes its story. Now magnify that discomfort to the scale of reality itself. If you know that an alternate self's decisions were altered because of your own influence, your narrative no longer makes sense. The story folds in on itself, producing not clarity but confusion, as though memory itself cannot decide what is true. It is worth considering whether paradoxes might self-correct. Some theories of the multiverse propose that when contradiction threatens stability, reality may branch again, creating new paths that accommodate both outcomes. In this view, influencing your other self would not erase divergence but multiply it, spawning even more branches. Yet this solution only postpones the problem. Infinite branching in response to paradox might dilute coherence to the point where probability space becomes saturated with contradictions. The structure of the multiverse could degrade, shifting from an elegant tree of possibilities into a chaotic tangle with no stability at all. On the other hand, perhaps paradox serves as a safeguard, an inbuilt resistance that prevents meaningful interference. If the laws of physics enforce consistency by blocking paradoxes from forming, then attempts to influence your other self may always fail. Messages may distort, memories may blur, actions may misfire, all conspiring to maintain separation. In this case, the mirror would remain a bridge of perception, but not of control. You could witness, you could share, but you could never rewrite. This limitation may be the only reason coherence survives. Still, the temptation would be immense. If offered the chance to save another version of yourself from heartbreak, or to prevent them from repeating your mistakes, could you resist? If given knowledge of their success, could you avoid shaping your own path in response? Paradox is dangerous precisely because it preys on human emotion. The very desire to protect, to improve, or to seize opportunity becomes the seed of destabilization. The mirror does not simply test physics, it tests willpower. Ultimately, the danger of paradox lies in its capacity to dissolve both reality and identity. To influence another self is to risk unraveling the separation that allows both of you to exist. The choice becomes stark. Respect the integrity of divergence or risk collapse. The mirror may tempt with the promise of shared wisdom, but beneath that promise lies a trap. If paradox takes hold, neither self may survive, and the coherence of the multiverse itself could falter under the strain. Time defines how we experience existence. It flows forward, one event following another, stitching memories into the story of self. But if the mirror truly opens a channel between alternate versions of reality, that orderly stitching begins to unravel. Interaction between two versions of you would not only affect choices in the present, but could distort the flow of time itself. Timelines may merge, diverge, or even overwrite each other, creating conflicts within memory that challenge what it means to know who you are. At the quantum level, time is less absolute than human perception suggests. The equations of physics often work equally well in both directions, forward and backward. It is only on the macroscopic scale that we experience time as irreversible, guided by entropy and the arrow of thermodynamics. Yet in a mirror scenario where two versions of self connect, the distinction between forward motion and alternate branching becomes blurred. If one you shares knowledge with the other, then the act resonates across different temporal paths, creating an entanglement not just of states, but of histories. Imagine this. You stand before the mirror, and memories flow into you from another version who lived a different life. In your mind, those memories would feel as vivid as your own, carrying the same emotional weight, the same sensory detail, but they would not align with the timeline you have lived. Suddenly, you might recall events that never occurred in your world, a birthday spent in another city, a career path you never pursued, a relationship you never began. Your brain, designed to create coherence, would struggle to integrate these contradictions. The result could be memory overwrite, where one version of reality begins to replace the other in your mind. Memory is not a fixed recording. It is fluid, reconstructed each time it is recalled. Neuroscience shows that recollection is an act of rebuilding, prone to distortion and change. If information from another timeline enters this reconstruction, the brain may not distinguish between its origin and your lived experience. Alternate memories could be woven into your narrative seamlessly until you no longer know which path was truly yours. This raises the chilling possibility that your sense of self could shift entirely, not through gradual forgetting, but through sudden substitution by another version's history. Timelines themselves might respond in unpredictable ways. If interaction through the mirror causes two realities to exchange information, then divergence could decrease, aligning them closer together. Shared knowledge may synchronize paths, effectively merging them into a hybrid reality that contains elements of both. But just as easily, the exchange could create further splits, generating more divergence as each self reacts differently to the influx of foreign memory. One version may accept and integrate the knowledge, while the other resists or misinterprets it. In this way, what begins as contact between two branches could ripple outward into countless new offshoots, multiplying the tree of possibility. The paradox of merging timelines lies in the question of consistency. If two selves share memory, which version becomes true? The problem echoes debates about time travel, where altering the past either erases the original timeline or creates a branching multiverse. In the mirror case, however, both versions already exist. Merging memories would create a hybrid identity that has no singular origin, a self that cannot claim one continuous history, but instead carries multiple overlapping narratives. This new self would be neither entirely you nor entirely the other, but something in between, a synthesis born of quantum overlap. The psychological consequences would be profound. Our identities are anchored in memory. To lose memory is to lose self. Overwriting memory with alternate experiences might expand awareness, but could also erode individuality. You might feel both empowered and destabilized, capable of drawing on lifetimes of experience, yet unsure which life is truly yours. This could lead to existential crisis. If your memories are not consistent, how do you know who you are? Alternatively, it might lead to a new model of identity, where the self is not defined by a single thread of continuity, but by an entire spectrum of lived possibilities. From the perspective of physics, the mirror might act as a conduit for temporal interference. Just as waves can overlap in space, timelines might overlap in probability space, producing interference patterns. In those patterns, some events reinforce each other, while others cancel out. Applied to memory, this would mean that certain recollections strengthen as they align across realities, while others fade into obscurity, cancelled by contradiction. Over time, the mind would retain only the reinforced memories, shaping a stable narrative from the interference pattern of multiple lives. Such a mechanism could explain phenomena humans already experience in subtle ways. Déjà vu, for instance, might represent a brief overlap of timelines, a memory from another branch surfacing in your awareness before vanishing. Dreams may be another echo, allowing fragments of alternate histories to slip into consciousness during vulnerable states. The quantum mirror, however, would amplify these effects, turning fleeting glimpses into sustained encounters, forcing the mind to reconcile not only moments, but entire lifetimes. There is also the question of causality. If you carry memories from another reality, your choices in this one may shift. Those shifts may ripple backward, changing the very conditions that allowed the alternate memories to reach you. Unlike paradox, where realities collapse, this process could create feedback loops that continually reshape timelines, blurring them until cause and effect become indistinguishable. Existence would feel less like a line and more like a network, where memory is not a simple record of the past, but a dynamic map of interwoven possibilities. Ultimately, time and memory are inseparable from identity, and the quantum mirror threatens to untether both. The merging of timelines through shared memory would challenge the assumption that life is a single sequence of events. Instead, it suggests that identity may be a quantum phenomenon, itself fluid, overlapping, and constantly rewritten by contact with alternate selves. The question is whether the mind can survive such fluidity, or whether the weight of contradictory histories would fracture it beyond repair. Speculation has always been the seed of discovery. Many of the most groundbreaking scientific achievements began as questions that seemed too strange, too improbable, until someone decided to test them. If mirrors might act as gateways or conduits of quantum information, the natural question follows: how could one build an experiment to measure it? The goal would not be to confirm wild ideas outright, but to create a structured test, carefully designed, that could reveal subtle anomalies in reflection signals that something beyond ordinary optics is occurring. The first step would be establishing what qualifies as normal. Mirrors have been studied extensively in classical physics. Light reflects predictably according to well-defined laws. Surfaces can be engineered to almost perfect smoothness, and interference patterns behave exactly as mathematics predicts. Any experiment looking for quantum leakage would need a baseline of traditional results, so deviations, however small, could be distinguished from noise. This requires isolating variables that are typically ignored. The smallest distortions in phase, unexpected fluctuations in polarization, or correlations in reflected photons that should not exist under classical conditions. A practical setup might begin with a highly controlled optical chamber, shielded from external radiation and vibrations, operating at temperatures close to absolute zero to minimize thermal noise. Inside this chamber, lasers could be directed at specially engineered mirrors not designed for human use, but for quantum sensitivity. These might include ultra-thin layers of superconducting materials, photonic crystals, or even metamaterials designed to bend light in unconventional ways. If mirrors truly act as thin membranes between realities, then exotic structures might amplify that effect, allowing measurable signatures to pass through. The experiment would rely heavily on quantum optics, specifically entangled photons. By generating pairs of entangled particles and directing one photon at the mirror, while keeping its partner in a detector, scientists could monitor whether reflection disrupts or modifies entanglement in unusual ways. If the mirror acts only as a surface, entanglement should remain intact, obeying known rules. But if the mirror leaks information into another domain, then subtle shifts might appear, correlations breaking where they should not, or unexplained delays in state collapse. These would be the fingerprints of something more than classical reflection. Another approach could involve quantum tunneling analogs. Normally, tunneling allows particles to pass through barriers they classically should not. If a mirror is not entirely a barrier but a membrane, then certain low-probability tunneling effects might be observable. To test this, researchers could measure photon disappearance rates, carefully checking whether more photons vanish from the system than can be explained by absorption or scattering. Even a fraction of a % deviation, repeated consistently, would demand new explanations. The real challenge would be distinguishing true anomalies from experimental error. Quantum systems are notoriously delicate, and interference can arise from countless overlooked sources: dust, electromagnetic noise, even fluctuations in cosmic radiation. To claim a mirror anomaly, researchers would need to reproduce results across multiple setups, with independent teams verifying the same deviations under different conditions. Only patterns that persist across replication could be taken seriously. If such anomalies were observed, the next phase would be even more daring. Instead of just measuring losses or correlations, the experiment could try encoding information into reflected photons, then monitoring whether traces of that information appear elsewhere. For example, patterns of polarization could be arranged in sequences, like a code. If any part of that sequence statistically reappears in entangled measurements or unrelated detectors, it would suggest information leakage across boundaries. Even a faint signal slightly higher than random chance would point to a mechanism no current physics can explain. The implications of success would be staggering. It would mean mirrors are not inert tools of optics, but active participants in the quantum fabric of reality. They would no longer be seen as simple reflectors of light, but as dynamic interfaces capable of channeling information between domains. This would bridge theory and observation, giving a foundation for further exploration into the possibility of cross-reality interaction. Naturally, skepticism would remain fierce. The history of science is filled with anomalies that later vanished under more precise measurement. Extraordinary claims demand extraordinary evidence, and so any report of mirror-based quantum leakage would need to withstand relentless scrutiny. Still, the very attempt to design such an experiment forces us to sharpen our understanding of light, reflection, and entanglement, driving progress whether or not the speculation proves correct. Even in failure, such an experiment could refine technology in profound ways. Precision mirrors are critical in gravitational wave detectors, quantum computers, and advanced imaging systems. Searching for anomalies could lead to new materials, better isolation methods, and more sensitive detectors. In this sense, the pursuit of the mirror question would benefit science regardless of outcome. Much like the early studies of black holes improved relativity long before detection confirmed their existence. But imagine just for a moment that the anomalies hold. A mirror experiment reveals consistent leakage of quantum information, unexplained correlations, or losses that cannot be reconciled with standard models. That discovery would shift mirrors from everyday objects to scientific mysteries, opening the door to further exploration. Laboratories worldwide would rush to replicate and expand the findings, seeking to understand whether the leakage is directional, controllable, or even harnessable. What began as a speculative test would ignite an entirely new field. The physics of boundaries, the study of how reflective surfaces interact with the quantum multiverse. At its core, the quantum mirror experiment embodies the essence of science, daring to ask questions that challenge what seems obvious, and building the tools to test them with precision. It is the bridge between imagination and measurement, between the mysteries of myth and the rigor of physics. Whether the mirror proves to be only glass and silver or something far stranger, the attempt to look deeper would mark a turning point in how we understand the boundaries of reality itself. Picture the room around you as it always has been, familiar in every detail, yet charged with a subtle tension you cannot quite name. The mirror before you, something you have walked past countless times without thought, suddenly feels alive. Its surface no longer rests in passive stillness. Instead, it gives the impression of depth, as though the glass has thickened into a liquid veil that waits for acknowledgement. At first, you hesitate, unsure if the sensation is internal or if the mirror itself has shifted. But then, your reflection begins to move not with you, but slightly out of sync, introducing the first undeniable break in the rules of perception. Your breath catches as your reflection delays by just half a heartbeat, as if it is no longer tethered to your motions but acting on its own decisions. The figure staring back wears your face, carries your posture, and mirrors every detail of your existence. Yet it feels alien. Its eyes weigh differently. Its expression contains thoughts you cannot access. You raise a hand, and the reflection raises one too, but not with mechanical precision. It hesitates, then adjusts, as though it is considering the choice rather than responding automatically. In that moment, the understanding settles over you. You are no longer looking at a reflection. You are looking at another self, standing in a different but parallel room, separated by a veil thin as breath. The air thickens, and sound seems to dull, the ordinary noises of the world receding as your focus sharpens on the figure in the glass. Instinct tells you to step back, to retreat to the safety of the familiar, but another impulse, stronger, compels you forward. The glass no longer feels like an obstacle. It seems porous, shimmering at the edges, as though the boundary between your world and theirs is loosening. You lean closer, expecting only the cold resistance of glass, yet your fingertips sink a fraction deeper than they should, as though the surface gives way like water. Your other self notices. Its expression shifts into something unmistakably aware. The eyes widen, recognition dawning not as a trick of imagination, but as a shared realization between two thinking beings. For a suspended instant, both of you stand at the edge of decision, each knowing the other faces the same choice. You press your palm harder against the surface, and instead of stopping, it slides inward, swallowed by the cool ripple of the mirror. The sensation is neither pain nor warmth, but something unclassifiable, an absence of resistance, as though your body is no longer bound by ordinary matter. Then the veil yields completely. You step through, and gravity itself seems to pause. For a moment, you are nowhere, suspended in a corridor of mirrored reflections stretching infinitely in every direction. Each panel shows another version of you, older, younger, altered by choices you never made. Some look back with curiosity, others with fear, a few with expressions you cannot name. It is overwhelming, the sudden confrontation with the vastness of what you might have been. Yet among this infinity, One figure stands closest, the version you first saw, the self whose eyes reflect your own awareness. Crossing the threshold feels like stepping out of time. The world you left behind no longer feels anchored, and the new space does not yet feel real. But then the floor solidifies under your feet. The air carries weight again, and you stand face to face with your alternate self. There is no delay now, no mimicry. They stand independent, breathing, observing, alive. The silence between you is both unbearable and magnetic, thick with the gravity of recognition. It is like looking into a living memory, one that can stare back and judge. Your first impulse is to speak, but words collapse in your throat. What language could bridge this encounter? Your mind races with questions. Who are you? How different is your life? What choices shaped you into what I am not? Yet even without speech, communication hums in the air. The presence itself conveys meaning, as though thought alone is enough to establish connection. And then, almost imperceptibly, you sense an exchange begin not of sound, but of understanding. Memories surface unbidden. Not yours, not theirs, but something shared. A memory of walking a different street, of knowing a different love, of failing where you succeeded or thriving where you stumbled. The exchange is seamless, like two streams of water meeting and merging. The shock is visceral. To feel memories that did not belong to you is both exhilarating and destabilizing. You blink, and in that blink you carry the echo of another life. The weight of it presses on your mind, a reminder that identity may not be fixed but fluid across countless branches. Your alternate self watches closely, as though gauging whether you will fracture under the weight or expand to contain it. Then comes the moment of touch. They reach out, their hands steady, and you feel compelled to meet it. Your palms connect, no glass between, only skin to skin. The sensation is grounding yet electrifying, a confirmation that the boundary is no longer theoretical but broken. The contact seems to anchor both of you, solidifying the link between realities. For an instant, your thoughts are not your own alone. They are interwoven, layered like chords in harmony. You sense their doubts, their regrets, their victories. They in turn feel yours. It is not confrontation, nor is it unity. It is a coexistence that neither language nor logic can neatly contain. The encounter is more than recognition, it is transformation. To see yourself reflected not as a passive image, but as a living counterpart, forces your mind to expand beyond its accustomed limits. You realize, perhaps for the first time, that your identity is not a solitary line, but part of a greater network, a tapestry woven from infinite selves, each one real, each one existing just beyond reach. And then, just as suddenly as it began, the connection trembles. The air grows taut. The mirror behind you shimmers with instability, as though reality resists this prolonged merging. You feel a pull, urging separation, warning that staying too long could unravel both worlds. With one last glance, one last flood of recognition, you step back. Your alternate self mirrors the action, not in mimicry, but in mutual understanding. The boundary reasserts itself, solidifying once more into ordinary glass. You find yourself staring again at a reflection, though now you know it is more than that. The knowledge lingers, the memory of the encounter etched into you as indelibly as any event of your life. The step-through has ended, but the weight of it remains. You are left with the realization that the mirror is no longer simply an object in the room, but a threshold, a possibility, a reminder that the self you know is only one among many. The encounter changes everything, not because you left with answers, but because you now understand the questions were real all along. Every life is built upon choices, and with each decision made, countless others are left behind. When imagining contact with an alternate self, the most profound consequence is not merely the shock of their existence, but the lessons they might carry from paths you did not take. This exchange would not be casual conversation. It would be an encounter with living evidence of your own potential, both fulfilled and wasted. The alternate you becomes a mirror not of appearance, but of consequence, holding a map of regrets, triumphs, and dangers that you have yet to see. Consider first the possibility of regret. An alternate version of you might reveal what it means to follow through on decisions you avoided, accepting a job you turned down, pursuing a relationship you abandoned, or moving to a place you never dared to live. Some of those choices may have led to flourishing, others to collapse. Hearing it directly from yourself would strip away the distance normally separating you from the hypothetical. It would no longer be abstract speculation, but an undeniable truth embodied in someone who knows your instincts, your fears, your weaknesses. To hear them say, "I took that road, and here is what it cost me," would strike with a weight no one else's words could carry. The lessons might also be ones of lost opportunity. Your counterpart could show you the richness of a life you denied yourself, not out of failure, but out of hesitation or doubt. They could describe the fulfillment of passions you neglected, the joy of risks you avoided, the friendships you never nurtured. These lessons would sting because they highlight not mistakes of commission, but omissions paths that quietly slipped away, while you told yourself there would always be time. Such encounters might inspire a fierce urgency, a refusal to keep delaying choices that matter. They might force you to reconsider what you truly value and whether you are living in alignment with it. Yet, lessons from the other side may not be gentle guidance. Some could come as warnings. An alternate self who followed darker roads might reveal how easily ambition becomes obsession, or how indulgence leads to ruin. They might not speak in riddles, but in raw testimony. The cost of betrayal, the toll of neglect, the weight of actions you rationalized in your own world but pursued in theirs. These warnings could act as both shield and burden. Shield, because they allow you to avoid mistakes before making them. Burden, because once you know the danger, you can no longer claim ignorance. The more subtle lesson lies in perspective. When two versions of the same person meet, both realize that identity is less fixed than believed. If your counterpart embodies traits you suppressed, then seeing them succeed or suffer with those traits forces a re-evaluation of yourself. Perhaps you buried a talent out of fear. They embraced it and thrived. Perhaps you suppressed anger. They let it consume them. In both cases, the message is not to copy or reject, but to understand the spectrum of your own potential. You are not only what you chose to become, but what you could still become, for better or worse. Some encounters might even transcend practical guidance, venturing into existential revelation. Your alternate self could remind you that success and failure are not absolute, but context-dependent. What looks like loss in one world may foster growth in another. The marriage that ended painfully here may have never begun there, sparing suffering but also erasing the lessons it brought. The career that feels stagnant in your reality might never have existed in theirs, leaving them envious of the stability you dismiss. Such comparisons illuminate how subjective fulfillment truly is, and how dangerous it can be to measure your worth against a single outcome. The emotional impact of these lessons would be immense. Imagine hearing your alternate self describe the sorrow of wasting years in pursuit of something hollow, or the joy of living authentically in ways you never dared. Their voice would not feel like an outsider's lecture, but like your own conscience finally given a body. It would be difficult to dismiss. These lessons could break complacency, dissolve denial, and awaken an intensity to live differently. Or, just as easily, they could overwhelm you, burying you in guilt over choices you cannot undo. What makes these teachings powerful is that they emerge not from abstract philosophy, but from lived reality different, yet yours in essence. This makes them uniquely potent, sharper than advice from any mentor or warning from any friend. They come from someone who knows exactly how you think, how you justify, how you hesitate, They anticipate your objections because they are yours. This gives them the authority to reach you in ways no one else can. Still, there remains the danger of over-reliance. If you treat your alternate self as a guide for every decision, you risk surrendering your autonomy. Their regrets may not apply to your world. Their warnings may reflect conditions that do not exist here. The lesson, then, is not to copy their life, but to interpret it with discernment, to see it as one more data point in the vast map of possibility. What matters is not what they tell you to do, but how their existence forces you to question your own path with greater honesty. Ultimately, the most profound teaching from the other side is this: you are not bound to a single version of yourself. Identity is not fate carved in stone, but a field of choices still open. Meeting an alternate self strips away the illusion of inevitability. It reminds you that every step forward can branch again, that potential is not exhausted simply because years have passed. The presence of another you is proof that the self is flexible, a structure still in flux, and that realization, more than any specific warning or regret, may be the true gift of the encounter. When we imagine mirrors not as passive reflectors, but as fragile gateways, the question of stability emerges. If two realities are separated by a thin boundary, what happens if that boundary fails? The collapse problem arises from the possibility that the barrier preventing universes from mixing might not be absolute. Instead, it could be contingent, delicate, and vulnerable to disturbance. Should it destabilize, the consequences would not be limited to strange visions or fleeting anomalies, but catastrophic blending on a scale that challenges our very definition of existence. To grasp the collapse problem, picture two rivers flowing parallel but kept apart by a levee. Each river has its own current, sediment, and direction. As long as the levee holds, they remain distinct. But if a breach occurs, the waters intermix chaotically, eroding both banks and creating a single turbulent channel that belongs to neither river. In the case of parallel realities, the levee is the quantum separation that preserves independence. If that barrier erodes, events, histories, and identities could overlap in ways that defy recovery. One immediate risk lies in identity conflict. If your alternate self inhabits a space that suddenly overlaps with yours, both realities might attempt to reconcile the contradiction. Memory could fracture as the mind struggles to contain two sets of experiences at once. For a moment, you might recall living entirely different lives, jobs you never worked, relationships you never had, decisions you never made. The psychological pressure would be immense, as if your consciousness was forced to hold incompatible truths simultaneously. Too much overlap could render individuality unstable, collapsing both versions of you into something neither fully recognizes. On a larger scale, the collapse problem threatens physical order. Universes evolve according to internal rules. Their constant gravity, charge, time do not necessarily align perfectly with ours. If their frameworks bleed into each other, even briefly, the result might be local instability. Structures built under one set of physical laws could dissolve under another. Objects might appear distorted, stretched, or erased altogether, as the governing principles of one world overwrite those of the other. In the most extreme case, entire landscapes could be rewritten, blending fragments of two incompatible geographies into one impossible terrain. The danger intensifies when considering causality. Each universe sustains its own timeline, a record of sequences that led to its present state. If two timelines intermingle, contradictions emerge. An event that occurred in one world but not the other could create paradoxical echoes. For example, suppose in one universe you exist, and in another you do not. If those realities collapse into each other, which truth prevails? The paradox might not resolve cleanly, but instead propagate instability outward, destabilizing not only individuals, but the coherence of the timeline itself. Time could fracture, looping or diverging endlessly, Until no consistent history remains, scientists speculating on such phenomena might describe it as entropic overflow. Each reality contains a reservoir of ordered information laws, memories, structures that define it. When barriers weaken, that information spills across boundaries, creating noise rather than clarity. Just as two incompatible computer codes running in the same system would crash the program, overlapping universes might overwhelm the fabric of order, leading to systemic collapse. What remains would not be a new stable universe, but fragmented patches of incompatible reality flickering without cohesion. Another angle of the collapse problem involves the human role in triggering instability. If consciousness itself acts as a bridge, then sustained focus on alternate selves might weaken boundaries over time. By acknowledging and interacting with another version of yourself, you might unintentionally erode the separation that keeps both worlds intact. At first, this erosion could manifest as subtle, bleed-through shared dreams, overlapping memories, déjà vu intensified into vivid sequences. But as erosion progresses, the line between one world and another could blur until both collapse under the strain of sustaining dual identities within one space. The most unsettling possibility is that collapse is not gradual but sudden. The boundary may remain intact until a threshold is reached, after which it fails catastrophically. Imagine standing in front of a mirror one moment and seeing only reflection, then suddenly watching the surface ripple as both rooms, the one you stand in and its counterpart, pour into each other. In an instant, the rules keeping them apart are undone, and what remains is a hybrid space that neither version of you can fully navigate. This abrupt collapse would be irreversible, leaving no way to reconstruct what was lost. Even more alarming is the idea that collapse might spread. If universes are not isolated but embedded in a larger multiversal fabric, a breach in one place could destabilize others. Just as a tear in fabric widens under stress, a collapsed boundary could trigger adjacent collapses, spreading outward like contagion. Entire chains of realities might unravel, blending into incoherence. From this perspective, the collapse problem is not a localized risk, but an existential threat to multiversal stability. One might ask, whether collapse always results in destruction. Could two universes merge seamlessly into a stable hybrid? Perhaps in rare cases, their laws and histories align closely enough to interweave without contradiction. In such a scenario, individuals might awaken with expanded memories, aware of both pasts, yet able to integrate them without fragmentation. Societies might gain technologies or ideas carried over from parallel histories, but such harmonious blending seems unlikely, as even minor inconsistencies could amplify into irreconcilable conflict. Stability requires near-perfect compatibility, which is improbable across infinite branching worlds. Ultimately, the collapse problem forces a sobering conclusion. Boundaries exist for a reason. They preserve coherence, protecting each reality from contamination by another. To tamper with those boundaries, whether through mirrors, experiments, or sustained consciousness, risks consequences far beyond curiosity. The collapse of a single boundary is not simply a blending of experiences, but a fundamental unraveling of order itself. When people speak of the soul, they often describe something indivisible, eternal, and deeply personal. Yet, if we place this idea under the lens of physics, it raises an extraordinary question. Could the essence we call the soul actually be quantum in nature? If consciousness is tied to quantum processes, then the soul might not belong exclusively to a single timeline. Instead, it could exist as a distributed entity, branching and evolving across countless realities simultaneously. This hypothesis, while speculative, offers a framework for understanding identity, mortality, and the strange possibility of multiversal continuity. To approach the idea, consider how quantum systems behave. A single particle, like an electron, is never limited to one defined state until observed. It resides in a superposition, embodying multiple outcomes that only collapse into certainty when measured. If consciousness emerges from such quantum processes, then the soul may not be tethered to one definitive version of events. Instead, it could unfold like a probability wave, spreading across realities and manifesting uniquely in each, while still remaining interconnected at a deeper level. This suggests that what we perceive as individuality may only be a partial perspective. You live your life in one timeline, believing your choices define a single path. But if your consciousness is quantum, then other versions of you also exist, each shaped by alternate choices. The soul, in this hypothesis, is the unifying thread binding these variants together. Each branch reflects a different aspect of possibility, yet all are part of one greater quantum self. What you call you may therefore be only a fraction of a wider existence unfolding across many worlds. The implications of such an idea are profound. Death, for example, would not signify total erasure. In one timeline, your body fails and consciousness ceases, but in another, the probability wave continues. The quantum soul hypothesis suggests continuity beyond individual lifetimes, as the broader network of your existence persists in other branches. This does not imply immortality in the traditional sense, but rather persistence of identity across the multiverse. It reframes mortality as a localized transition, rather than an ultimate end. Memory also gains new dimensions under this lens. If the soul is quantum, fragments of awareness might occasionally bleed between timelines. Experiences from another version of you could echo faintly into your own life, manifesting as déjà vu, intuition, or dreams that feel inexplicably real. These moments may be nothing more than subtle quantum overlaps, tiny glimpses of the greater self beyond your singular path. Instead of being errors of perception, they could be evidence of consciousness stretching across parallel realities. The philosophical consequences are equally striking. Free will, often debated as illusion versus truth, may find new context here. Each choice you make generates a branching of outcomes. But if the soul spans them all, then freedom is not confined to one decision, but expressed across all possible decisions. You are both the one who chose and the one who didn't. The soul is not limited to success or failure, but experiences the full range of possibility. From this view, regret loses some of its weight, because every path has been walked by another version of you within the larger framework of the quantum self. Skeptics might argue that such speculation drifts too far from science, but the foundations are not entirely detached from real inquiry. Quantum biology already explores whether living systems exploit quantum effects for processes like photosynthesis and navigation in birds. Some theorists extend this to the brain, proposing that quantum coherence plays a role in neural activity. If even a fraction of consciousness depends on quantum dynamics, then the leap to considering a quantum soul becomes less implausible. The question shifts from whether it exists to how it might function across multiple realities. One potential model is entanglement. When particles are entangled, they remain connected regardless of distance, their states mirroring each other instantly. If consciousness operates through entangled quantum states, then your alternate selves may remain linked across universes. Each version of you may feel separate, but beneath that separation lies a network of entangled awareness that ties them into one greater whole. The soul, in this sense, is not confined to a body, but exists as a field of entangled information spanning the multiverse. This model also reframes spirituality. Many traditions describe the soul as transcending physical boundaries, existing in states beyond material life. The quantum soul hypothesis offers a scientific metaphor for that intuition. Instead of floating as a mystical essence, the soul is an informational structure embedded in quantum reality. Its endurance is not supernatural but rooted in the resilience of quantum states that cannot be fully destroyed, only transformed. This does not diminish its mystery. It simply translates it into the language of physics. There is also a darker implication. If the soul spans multiple realities, then it may carry burdens across them as well. Trauma, obsession, or unresolved struggles in one version of you could resonate faintly into others. This might explain why individuals sometimes feel unexplained heaviness, as if carrying memories that never occurred in their lives. These echoes may be cross-reality imprints, the struggles of your other selves reverberating through the quantum field of the soul. If true, healing might involve more than resolving your own experiences. It could mean addressing the wider network of the self. At the same time, this hypothesis suggests extraordinary possibilities for growth. If one version of you learns profound wisdom, could that insight filter across realities into others? Perhaps the sudden clarity people experience in pivotal moments is not spontaneous, but carried from another path, where the lesson was already learned. The quantum soul may allow knowledge, resilience, or even creativity to ripple across the multiverse, enriching each branch of existence with contributions from the others. Ultimately, the quantum soul hypothesis invites us to reconsider identity itself. You are not a single, isolated being, but part of a vast, distributed existence. Every choice you make, every path you follow, is one thread in a tapestry woven across infinite realities. What you experience now is precious, but it is not the entirety of you. The soul may be larger than any single life, stretching across countless worlds, enduring not as a singular flame, but as a constellation of light scattered through the quantum fabric of reality. Imagine a world where mirrors no longer serve as simple reflective tools, but as instruments of revelation, offering glimpses into other versions of ourselves, and even shared experiences with alternate realities. If such technology or natural phenomena became universally accessible, humanity would undergo transformations so profound that our understanding of self, society, and existence would never return to its previous state. The first shift would occur at the level of personal identity. For centuries, individuals have built their sense of self on continuity, memory, and choice. A mirror capable of exposing alternate realities would shatter that foundation. People would see not only who they are, but who they could have been, versions shaped by paths not taken. Careers, relationships, and lifestyles once relegated to imagination would become visible, embodied by an alternate self standing just beyond the reflective boundary. This would force a re-evaluation of accountability and regret. Would you feel responsible for the choices of your other selves, or liberated knowing that every possibility was lived somewhere? Identity would cease being linear and become multidimensional, woven from countless lives rather than one narrative. Relationships would change just as drastically. Marriage, friendship, and family bonds are often built on exclusivity, the belief that two people share unique experiences. But what happens when mirrors reveal alternate relationships, showing your partner in a life without you, or with someone else entirely? Some might find reassurance in seeing their connection endure across realities, while others would confront jealousy, insecurity, or despair at witnessing other paths. Love itself might be redefined, no longer confined to this timeline, but recognized as something that spans countless variations, each with its own weight. The human heart would be forced to grapple with multiplicity, balancing devotion with the knowledge that other versions of intimacy exist simultaneously. Religion and philosophy would not remain untouched. Traditions centered on singular creation stories, singular afterlives, or linear timelines would need reinterpretation. The quantum mirror would provide empirical evidence that reality itself is layered and infinite, and belief systems would either fracture under the weight of this discovery or evolve to incorporate it. Concepts like destiny, divine will, or reincarnation might gain new meanings, framed not as mystical abstractions, but as reflections of multiversal continuity. Spirituality could either collapse into disillusionment or expand into a broader recognition of existence as a network of interwoven lives, science would experience both a renaissance and a crisis. On one hand, the quantum mirror would open doors to studying parallel universes directly, offering testable evidence of theories that were previously speculative. Entire branches of physics, neuroscience, and cosmology would reorganize themselves around this phenomenon. Yet the accessibility of the mirror would also destabilize traditional scientific authority. If ordinary individuals could peer into alternate realities from their own homes, science would no longer control the gatekeeping of knowledge. Discovery would decentralize, with personal observations rivaling professional research. The democratization of such power might accelerate progress, but also risk chaos, as unverified claims and subjective interpretations flood the discourse. The economy would inevitably shift as well. Industries built on identity psychology, self-help, entertainment would face upheaval. Why seek fictional stories when mirrors show you real versions of yourself living them? Why attend therapy when you can see a version of you who resolved the very struggles you face? At the same time, entirely new markets would emerge. Businesses offering training in mirror navigation, ethical consultations about interacting with alternate selves, and even tourism into mirrored realities if physical passage ever became possible. Wealth and power would tilt toward those who could harness the mirror's potential most effectively, whether through research, control, or exploitation. On a global scale, the mirror's influence could destabilize political systems. National identities depend on shared histories. But what happens when alternate histories are revealed? Citizens could see worlds where wars ended differently, borders shifted, or leaders never rose to power. Such revelations would fuel discontent, undermining the legitimacy of governments tied to the current version of reality. Entire nations might fracture as people gravitate toward alternate visions of their culture, insisting that their true identity belongs to the path they glimpse in the mirror rather than the one they inhabit. Political power would no longer rest solely on material control, but also on the ability to shape narratives about which realities deserve recognition. The social fabric itself would stretch thin. Communities might form around shared alternate experiences, groups of people drawn together because they saw themselves in similar mirrored lives. Subcultures could emerge that prioritize certain realities over others, leading to new divisions as strong as those once formed around religion, politics, or language. At the same time, empathy might expand. Seeing yourself in countless forms could dissolve prejudices, as it becomes impossible to maintain rigid categories when you realize that somewhere you embody every background, profession, or ideology you once judged. The mirror could either fragment humanity into infinite factions or unite it under the recognition of shared multiversal identity. Education would undergo transformation as well. Children raised with access to mirrors would grow up aware that their futures are not linear but branching. Instead of asking, "What do you want to be when you grow up?" the question might shift to, "Which version of yourself do you wish to cultivate here?" Traditional career planning might collapse, replaced by a more fluid approach that acknowledges the existence of multiple paths simultaneously. Some might find this freeing, embracing experimentation without fear of wasted potential, while others might struggle with decision paralysis, overwhelmed by the awareness of infinite alternatives. The ethical challenges would be immense. Should you interact with your alternate self? Or is it exploitation to borrow their wisdom? If societies discover realities where their people suffer less, are they morally obligated to find ways of merging with or aiding those worlds? And if collapse is a risk, as earlier theories suggest, is it ethical to even use the mirror at all? Humanity would face dilemmas with no precedent, forced to balance curiosity, survival, and moral responsibility in a landscape where every choice echoes across multiple versions of existence. Perhaps the most profound change would be in our collective sense of meaning. For millennia, humans have coped with mortality, regret, and limitation by telling stories of transcendence myths, philosophies, religions. But if the mirror reveals that transcendence already exists in the form of parallel selves, then the search for meaning must adapt. Some may feel diminished, believing that individuality is an illusion. Others may feel empowered, recognizing that their soul is part of a greater tapestry of existence. Humanity as a whole would stand at a crossroads, to collapse under the weight of infinite possibilities, or to rise and embrace the multiverse as the true stage of human life. The quantum mirror would not merely change what we know, it would change who we are. Every assumption about self, society, and reality would be rewritten, not by abstract theories, but by direct experience visible in every reflective surface. Humanity would awaken to a world where the ordinary act of looking in a mirror reveals not just appearance, but infinity. From the very beginning, the mirror was nothing more than glass and silver, a simple tool for grooming, for vanity, for confirmation that the face staring back is truly yours. Yet as we have stretched the imagination to its furthest edges, the mirror has transformed into something else entirely, a symbol of infinite possibility, a bridge to parallel selves, and perhaps even a channel to the deepest layers of human consciousness. To arrive here is not to solve the mystery, but to recognize what it reveals about us, about the meaning of meeting yourself beyond the surface of glass. If the mirror were truly a quantum gateway, then the greatest revelation is not scientific proof of parallel universes, but the recognition of how vast the human being really is. Science offers the mechanics superposition, entanglement, probability, but these are only the language of description. The deeper truth is that within each of us lies an expanse larger than any single life can hold. To meet yourself through the mirror is to confront the infinite nature of your own potential, not as metaphor, but as lived reality. Think of what it means to stand before your reflection and know that another version of you stands there too, not as illusion, but as flesh and thought. That realization collapses the distance between imagination and existence. All the choices you questioned, all the regrets you carried, all the futures you dreamed but never pursued, they are not gone. They live in parallel with you, equally real, equally valid. To meet yourself is to understand that you are not defined by what you did or did not do, but by the spectrum of what you could be. The lesson here is neither comfort nor fear, but responsibility. For if countless versions of you exist, then every path matters. You are not condemned to the weight of perfection, because in one world you will fail, in another you will succeed, but you are called to embrace the life in front of you as fully as possible. The mirror does not free you from your reality. It reminds you that this version is yours to live, and ignoring it for visions of elsewhere is to abandon the gift of the present. At the same time, meeting yourself reveals the unity of human experience. You are unique, yet you are infinite. Every alternate version shows you not a stranger, but yourself, carrying the same spark in different shapes. This realization dissolves isolation. It teaches that no one is ever entirely lost, because somewhere, some version continues. It also reframes the soul not as an isolated flame, but as a constellation, each light connected to the others, forming a pattern too vast for one life to comprehend. The scientific pursuit of such a mirror, if ever possible, would not end in equations, but in transformation of perspective. Physics may explain how particles align across realities, but the greater revolution lies in philosophy and human self-understanding. To meet yourself is to confront the truth that existence is larger than comprehension, yet intimate enough to hold in your hands each time you touch glass. Perhaps that is the final reflection, that the mirror, whether ordinary or quantum, has always been about recognition, recognition of self, recognition of potential, recognition of the infinite branching lives contained within a single person. Whether or not the quantum mirror is real in physical terms, it has already revealed something essential. We are more than linear beings marching from birth to death. We are expansive, layered, and timeless in ways that defy limitation. To meet yourself truly is to see beyond the boundaries of a single life and recognize that the infinite is already within you. That is not just science. That is the essence of what it means to be human.